Hi everyone, welcome to our lesson in measurement. In this video, we are going to learn how to write in scientific notation. I'm sure you have learned this in your math class at some point, so maybe for some of you, this will just be a bit of a review. Scientific notation is an important concept in science for you deal with different kinds of measurement, whether big or small numbers. And in order for you to save time writing those kinds of numbers, you should learn how to write in scientific notation. I do encourage you to copy notes as we move along on your tab 3 of your binder. What are the parts of the scientific notation? There are three important parts of the scientific notation, namely the coefficient, the base, and the exponent. The coefficient is the number that you technically translate in a normal number. And when you write the coefficient, you will see that there is the presence of a decimal point that should be written between two numbers. There should only be a one non-zero digit when you write a scientific notation or the coefficient. Base is the 10 that you write all the time when you translate it in scientific notation. And this base is raised by a number that is called the exponent, which determines if the number is a big number or a small number. This is indicated by a positive or a negative sign. So, what is a scientific notation? Scientific notation is the way that scientists easily handle very large numbers or very small numbers. Let's look at this example. If I ask you now, what do you think is this number? A very large number or a very small number? If your answer is a very small number, then you are correct. This is a very small number. So if you see here, the zeros is actually the one that indicates that this is a very small measurement or a number. So for us to save time, instead of writing all the zeros, why don't you write it in scientific notation? So how do you translate that? It will now be 5.6 times 10 to the negative 9. So this is your coefficient, this is the base of 10, and this is your exponent in a negative sign. Let's look at the translation between the scientific notation to a normal number and vice versa. All right, so you have a normal number here and you want to translate it in scientific notation format. So we will try to remove all the zeros. So this is a big number or a large number. This is a very small number or measurement. So here, if you see there is no presence of a decimal point that is clearly written, but we all know that the point is at the end of the number. So therefore, your goal is to bring that decimal point between 8 and 9. So therefore, you're going to the direction to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that would be 8.95 times 10 to the 14th power grams. It should be a positive one because you translated it from a very big number. How about this one? This one you will see that you have the zeros in front, so it's an indicator that this is a very small number. You see the decimal point over here, so your job is to bring it between 8 and 5. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's write it down. 8.5 times 10 to the negative 11 gram. The negative exponent indicates that you have just translated it from a very small number. Now, what if we change the situation? You have a scientific notation and you're being asked to translate it to a normal number. So you have two examples here. You have the same coefficient, same number in the exponent, but one is positive and one is negative. So let's translate this to a normal number. So this is a positive exponent, so meaning to say I should be able to translate this to a number that is actually a very large number. So I'm going to the right 7 times. 1, 2, 3, 4, 5, 6, 7. those spaces that you have drawn there, you have the privilege to add zeros. So that would be 3, 8, 7, 2, 3, 4, 5 grams. So that is a 38,700,000 grams. This number I see is a negative exponent, so meaning I should end up with a very small number. So I should now be going to the left. So that would be from this point, I'm going to do 1, 2, 3, 4, 5, 6, 7, and point is in front. So decimal point, 1, 2, 3, 4, 5, 6, 7, 87 gram. So you see, I end up with a very small number. All right, let's see if we were able to absorb the two translations that I have just shown you. Let's do the drills. So for the first one, you're going to translate it or convert it to scientific notation. So they are all written in a normal number. So here I could see that the zeros are in front, so this is a very small number. So I'm going to translate it to a scientific notation by bringing the decimal point between 8 and 7. So that would be 1, 2, 3, 4, 5, 6, 7. So let's write it down. 8, 7, 4 times 10 to the negative 7 meter. Why did I put a negative? Because it came from a very small number. Now, how about this one? I see that the zeros are at the end, so I know that the decimal point is at the end. So my goal is to bring the decimal point between 6 and 2. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that would be 6.23 times 10 to the positive 11 meter. Positive because it came from a large number. Now, how about we translate now to a normal number? So scientific notation to a normal number. So here I see that the exponent is a negative 5, so meaning I should end up with a small number. So therefore, I'm going to bring this decimal point to the left 5 times. 1, 2, 3, 4, 5, and bring the point in front. Point 1, 2, 3, 4. There you go. So this I end up with a small number. Next, I see a positive 8, so meaning I should end up with a large number. So this time I'm going to bring this point to the right 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So that would be 3, 7, 7, and 6 zeros liter. So you end up with a 377 million liters. I hope you were able to absorb these concepts of translating scientific notation to normal number and vice versa. You will be given a graded worksheet for you to be able to practice these concepts. On the next slide, I'm going to teach you how to correct a scientific notation format. There are instances that when you have a scientific notation, that doesn't mean that it is always written in correct format. So if that's the case and you need to correct it, you have to follow certain rules. And the rules are written in these two bullets. So this is in terms of the relationship of the coefficient and the exponent. So if you see here, coefficient increase, exponent decreases. Coefficient decrease, exponent increases. So it's an inverse relationship. So let's look at these two examples to see it clearly. Let me just change the color of my pen. So I have 566.4 times 10 to the negative 4. So technically, this point should be between 5 and 6 if you really want to follow the correct scientific notation format. So what we're going to do here is to correct it. So we're going to move 1, 2 over there. So that should now be 5 decimal point 664 times 10. Now, what happens here is your coefficient from 566 it became 5.664, so meaning your coefficient decreases, so therefore your exponent should increase. You move two places, so therefore you have to add 2 on your exponent. So negative 4 plus 2, that would give us a negative 2 exponent cm. Next example. You have 0.0048 times 10 to the 7th power cm. Again, this is not a correct scientific notation format because we do not allow zeros before the for the coefficient. So what we need to do is to bring the the decimal point between 4 and 8. Okay? So that would be 4 decimal point 8 times 10. All right. So from 0.0048, it became 4.8. So what happened to the coefficient? It increased. So therefore, the exponent should decrease. So how many places did you move? 3. So that should be minus 3. So 7 minus 3 is actually a 4. So you now have a new exponent of 4 cm. All right. Let's see if we were able to get this. Let's do some drills. So you have a 23.4 times 10 to the 6. Now this is not correct, so let's move this over here. So that should be 2.34 times 10. All right, what happened to the coefficient when you move it over here? It decreases, so therefore your exponent should increase by 1 because you only move one place. So that would now be a 7. Number 2, 588.2. So that's not correct. So let's move it over here between 5 and 8. That would be 5.88 times 10. All right. From 588 to 5.88. So it decreases. So your exponent should increase. And you move two places. So plus 2. So your new exponent is negative 1. Next, again, this is not correct, so let's move this between 3 and 3. That should be 3.3 times 10. All right, you move 1, 2, 3 places, and what happened to the coefficient from 0.0033, it becomes 3.3, so it increases, so your exponent should decrease. Sorry. Okay, so that will now give you a negative 9 exponent. And last example or last drill, you have 5336.9. So let's bring this point between 5 and 3. 5.336 times 10. What happened? From this number, it became 5.3, so it decreases. So this should increase by 3. That would be to the 10th power grams. I hope at this point you were able to absorb the two rules in terms of correcting scientific notation format. Again, you will be given a graded worksheet for this so that you will be able to master the concepts on scientific notation. I hope you were able to understand everything, and thank you for listening.